Hello and welcome to my channel. If you have not subscribed, please do so. My name is Mr. Miracle, and we've been dealing with trigonometric integrals. So I mentioned this to be two. We've solved problems initially, and so we are proceeding to more difficult problems. And today we have two problems to handle. So let's move straight into it. Now, from question 1, we say we have integral cos⁴x sin x dx. So how do we solve this? It's simple. What we simply do is we say let u be equal to cos⁵x. So if we do that, we will now say du dx, that is, we are differentiating this function with respect to x, is going to give us minus sin x. So we cross multiply y. We are trying to make the x the subject of the formula. So by cross multiplying, we have that du should be equal to minus sin x dx. So we divide both sides by minus sin x minus sin x. So this cancels out. We have the x alone. So the x is equal to what? Du minus sin x. So we are going to replace the x here with minus or du over minus sin x. So we do that here. So this is integral. We have said u is cos⁵x, so this is now u raised to the power of 5. What else do we have? Sin x. So instead of the x, we replace with the u. So we have the u over minus sin x. So this cancels out. So this should give us the integral of minus u power 5 du. This minus multiplies backward. And then we now have a single variable for our function. So we integrate. So this is going to give us, if we are integrating this, remember we are increasing the power by 1. So this will give us minus u raised to the power of 6 and still make it the denominator of the variable, all over what? 6 plus c. But recall that u is what? Cos⁵x. So this is going to give us minus 1 over 6 cos⁴x plus c, which is the constant of integration. So that is our answer. Straightforward, right? So let's solve question 2 quickly. So question 2 is going to be a bit bulky. So we have sin ⁵x cos²x dx. So first of all, what we do is to break this down. So we say this should give us integral the sin ⁴x cos²x sin x dx. We only reduce this by 1 to form this. Then also we can say this is integral sin²x all squared cos²x sin x dx. Now we can substitute. We say let u be equal to what? Let's not substitute just at this point. Recall, first of all, that sin²x plus cos²x is equal to 1. Why did I stop my substitution to bring this? I did that so as I could make the terms of cos on this, our integral, to be more than that of sin, so as we can easily substitute. Is that clear? Now, since we know this from trig identity, making this the subject of formula means taking this way and it becomes a negative. So this will give us sin²x equal to 1 minus cos²x. So this now replaces sin²x, since sin²x is equal to this here. So we now have integral, instead of sin²x, we have 1 minus cos²x all squared. cos²x sin⁵x dx. So you can now see that we have more terms of cos than sine. So we now do our substitution without any hiccups anywhere. So we say let cos, or let u be equal to cos⁵x. So if we differentiate u with respect to x, we'll be having minus sin⁵x. As we solved previously, if you're making dx the subject, the x should be equal to du all over minus sin⁵x. So we replace this for the x here. So this becomes integral. Also the variables are going to change because we say u is equal to what? Cos⁵x. So it means we have 1 minus u² all squared times cos² is u². What else? We have sin⁵x. Instead of the x, we now have what? du over minus sin⁵x. So this cancels out. This minus comes back. So we have integral minus into 1 minus u² all squared times u² du. We now have a single variable to handle. But this is 1 minus u² in a bracket raised to the power of 2. So it needs expansion. So in order for us to do that, we just do that by the side. We can expand that by the side. So 1 minus u² all squared is the same thing as 1 minus u² into 1 minus u². Okay? So this should be equal to, we use one bracket to expand the other, 1 into 1 minus u². The next is minus u² into 1 minus u². So 1 times 1 is 1. 1 times minus u² is u². Minus u² times 1 is minus u². Minus u² times, or minus times minus is plus. u² times u² is u power 4. So we now say this is 1 minus 2u² plus u power 4. So we replace this for this. So this is integral minus bracket 1 minus 2u² plus u power 4 times u² du. So now we are going to use this and this to expand the bracket separately, just for you to understand. So this is going to be minus times 1 is minus 1. Minus times minus is plus. So we have 2u². In case you're surprised, why am I using minus? There's an invincible one here. It has a coefficient of 1. So it can work. So minus times plus is minus. So we have u power 4 times u² du. Okay. Final step. We are expanding this bracket with this. So u times this times 1 is going to give us minus u² plus 2u power 4 minus u power 6 du. In case you don't understand why the powers are increasing, it is simple. If in indices, if you have a² times a², this is going to give us a raised to the power of 2 plus 2, which is equal to a raised to the power of 4. So that's how this with this give 4. Therefore, that of 6 is the same. This is going to give us 4 plus So this is a raised to the power of 4 times a raised to the power of 2 equals to a raised to the power of 4 plus 2. So this is equal to a raised to the power of what? 6. So that's how we got here. So finally, if we integrate this, we're going to be getting, remember the powers are increasing by 1 and we are dividing by the powers. So this is going to give us minus u cubed all over 3 plus 2u raised to the power of 5 over 5 minus u raised to the power of 7 over 7 plus c. So we would have left it here, but just for clarity, recall that we say that u is equal to what? Cos⁵x. So we just resubstitute that here. So that is going to give us minus, we're bringing out 1 over 3, 1 over 3 cos⁵x plus 2 over 5. Our u is cos, so we have cos power 5x plus, we have 1 over 7 cos power 7x plus c, and this is our answer. So just in case you find this video interesting, you can like it and subscribe if you have not. Share the video, and if you have any challenges, you need personal coaching, you can just reach out to us through the comments section. I think I will respond. So stay blessed, remain blessed. I remain your usual anchor. See you in my next video. Bye bye.